So, we made the assumption that the tilt factor for the day for the direct radiation can be calculated under extraterrestrial conditions, and the numerical values agree very well with the data values almost, particularly for south facing surfaces. Now, given the symmetry not being there, for example, when the surface does not face south, you will have to evaluate what shall be the kind of difference one will encounter if it had been made under terrestrial conditions. Either you use the data, or now we have the correlations due to Leon Jordan and Collares Pereira Rabel to express I d and I, and hence one can carry on either numerical integration or analytical integration, at least to evaluate the order of magnitude of errors that are likely to be encountered had the terrestrial values been used. This is important, particularly when the uniform clearness index condition is broken, which shall be coupled with the added difficulty in case the surface is not facing south due to some sort of asymmetric distribution around solar noon time. Before we go into that evaluation, last time we were talking about the cases of so called double sunshine, that is, the surface receives sometime during the day solar radiation with a no sunshine period in between, and again receives sunshine for certain period. There can be n number of degenerate cases, both being only in the afternoon, both being only in the forenoon, or distributed over forenoon and afternoon. We first identified a large number of cases where there is only single sunshine, and I think the cases of 1, 2, 3 where there is double sunshine we have already discussed, and case 4 is having a phi latitude of 17 degrees, beta of 90 degrees with a gamma of 175 degrees and declination being 23 degrees. This is June, something like that. So, you have a sunset hour angle of 97.93 degrees, and again omega SR and omega SS minus 31.79 and omega SS is minus 50.17. Now, what is interesting is these are the numbers obtained with the algorithm which we had discussed. That is, first you determine the magnitudes by using the cosine inverse, then determine the sign by using the sine root. Consequently, here it satisfies the condition mathematically omega SR is greater than omega SS. Minus 31.79 is mathematically more than minus 50.17. So, you have the theta versus omega curve. This is pi by 2, this is theta axis omega, this may be your minus omega s, which is 97.93, and this is plus omega s. So, now you have got something like this. So, this is your omega SS and this is it okay? SR is minus 31. Okay. right. So, omega s r is greater than omega s s because of the negative sign. And actually, if you had plotted, you will have this theta less than pi by 2 and here theta is less than pi by 2, defining the surface should receive the radiation from the sunrise up to this sunrise omega s r and again from omega s s up to whatever is the physical sunset. So, this is the part no radiation on the surface. That is where you do the piecewise integration minus omega s to omega s r and omega s s to omega s. The last one is a peculiar situation. You have equator phi is equal to 0 and beta of 70, gamma of 170, that means almost towards north, and declination of 22. Now, first of all you can see this phi and delta 22 is fine. So, you have omega s 90 degrees. I guess we had mentioned wherever you are on the earth on equinoctial day, that is when delta is equal to 0, your omega s is 90 and phi is equal to 0, omega is equal to 90, whatever may be delta. The declination, you have the sunset hour angle to be 90 degrees on the equator and on the equinoctial date, whatever is the latitude, you have got sunset hour angle to be 90 degrees. So, this will have you have minus omega s equal to omega s s equal to omega s r, right. You can just calculate this turns out to be equal to minus omega s by limiting omega s s and omega s r to the physical sunrise and sunset hour angles. So, if you plot theta versus omega, you will have this satisfying like this. So, it looks like it is a single sunshine correctly, right, but it is because of omega s s and omega s r coinciding with minus omega s. And this one has to calculate it and convince yourself. Basically, what it means is here really my theta will be less than pi by 2, but sunset has come about and consequently again it starts from seeing the same time, right. The one should exactly take these values and calculate theta and convince yourself that that is a figure. These are examples of no sunshine and under different cases. So, for example, first one which has got a figure like this, so theta is equal to pi by 2 at omega is equal to 0. We have stated also this is gamma equal to 0. Consequently, it is a symmetric case. So, it is a degenerate single sunshine. Because if gamma had been non-zero or beta is not 90, 80, 88 or something, I might have had a curve like this, which is normal, with theta being less than pi by 2 over a period within the sunrise to sunset, and it satisfies my d theta d omega less than 0 for sunrise. Hereafter, I will write in shorthand SR, and d theta d omega greater than 0 for sunset. Then again here low latitude, beta 90 degrees, gamma 160 north facing, delta negative. You can see more or less the number, case number 1 is inverted by choosing gamma 160 is almost like 0 to 180, 20 to minus 20, 5 and 18 both of them are less than the declination magnitude wise. So, you will have a certain situation where theta is equal to pi by 2 is satisfied only beyond omega s, right. Throughout the day it is more than pi by 2. Consequently, you set it equal to omega s, but really omega s are equal to omega s equal to minus omega s s after limiting to the magnitude of omega s. So, the real calculations show 88.18 is omega s r and omega s s. This is after limiting, okay. And you can case 2, no sunshine. So, you can calculate whatever we are saying omega s r dashed and omega s s dashed. So, these numbers are given after doing this. Now, here is a interesting situation, phi 18, beta 90, gamma 0, delta 18. This exactly looks like the previous case number 1, and you okay, right. In case number 1, this is 3. Theta at noon is exactly 90 degrees, whereas case 1 theta at noon is 92.01. Okay. Graph by hand I could not show that, it is slightly more than 90, does not matter, still it does not receive any radiation. As you can see, phi is equal to delta, okay, less than 23 degrees in the case number 3. So, at the noon time for a vertical surface, the sun's rays will be parallel, meaning thereby theta noon will be pi by 2, and other places it is more than pi by 2. And last one is phi 0, beta 90, gamma 0 and delta 0, that is the equinoctial day. So, if you put it, you will get theta case 4 phi 0, beta 90 and gamma equal to 0 and delta is equal to 0. So, it is a vertical surface, delta 0, phi is equal to 0. So, theta should be equal to pi by 2 at solar noon time, like in case number 3, but since it is the equator, theta is equal to pi by 2 all the time. You can easily calculate cos phi, cos delta, cos omega. Let us see if we can get that. So, this is gamma 0. So, cos theta is equal to cos phi minus beta 0 minus 90 cos delta 0 cos omega plus sin 0 minus 90 sin phi sin delta equal to. So, this is 0 because delta is 0 and cos 90 is 0, right. So, cos theta equal to 0 for all omega. This leads to theta is equal to pi by 2 for all omega. Okay. So, these are the types of situations one can encounter with single sunshine or double sunshine, including no sunshine, which may be a degenerate case of single sunshine or double sunshine. Then one can, I will leave it as an exercise, write a program to calculate omega s, omega sr, omega ss, theta z and theta. In the latitudes 0 less than or equal to 5 less than or equal to 90 degrees and minus 180 gamma plus 180, and you can take okay, all 12 months of delta m, then 0 less than or equal to beta less than or equal to 90 degrees. Okay. So, in your computer output you can have those omega SR dashed and omega SS dashed as given by the algorithm, and then determine the sign and magnitude of omega SR dashed and omega SS dashed and limit omega s if need be. In other words, what I am trying to point out, if you look at only the final numbers, it may be misleading and you might have got a correct answer even if the calculation has been wrong. Suppose omega s is equal to 92 and you got 118 instead of 172, even then omega SR will show up as 92. So, that may be a correct answer, but may be a wrong logic in calculating either omega SR dashed or omega SS dashed. So, you can always ask it and then plot theta versus omega, and if there is a double sunshine, single sunshine, your value should justify the theta variation with respect to omega. So, what we have identified is that at times calculation of RB bar without taking cognizance of whether it is a single continuous period or two periods with a no sunshine period in between, either it leads to an underestimate or maybe even a negative value, and consequently some computer manipulation, like if it is negative, take it as 0, and that is one danger. The other thing is it may be a simple underestimate. Instead of 0.87, you may get the answer as 0.62, which looks deceptively close and correct, but nevertheless one has to verify in these things. So, once again I will recall your equation for the RB bar as omega SR to omega SS cos theta d omega it is minus omega s to plus omega s is twice of 0 to omega s, because it is a symmetric function. This is true, we said that single sunshine period. At that point of time, we did not have this wisdom of how do you distinguish between single sunshine period and double sunshine period, and we generally assumed it will be from sunrise to sunset, apparent or otherwise. So, if you integrate it under integral terrestrial extraterrestrial conditions, this is what you will have, that a into omega s s minus omega s r, and I emphasized with pi by 180, if you use omega s s and omega s r in degrees, it should be converted to radians. Now, if it receives double sunshine, R b bar should be piecewise evaluated minus omega s to omega s s cos theta d omega plus omega s r to omega s cos theta d omega upon twice 0 to omega s of cosine theta z d omega. It is only a formal integration, it is just your cos theta is nothing but a plus b cos omega plus c sin omega, where a, b, c are independent of omega. So, consequently, at this stage they do not bother us. So, it gives rise to two terms, which is first term integral is cos theta is a, that is a into omega s s minus omega s will be plus omega s, like that you have two terms. Okay. So, one can evaluate R b bar under extraterrestrial conditions, even if the surface receives sunshine during two periods. So far, we assumed that the evaluation can be done under extraterrestrial conditions, and the accuracy had been reasonable, at least for south facing surfaces, by comparing with the data. And now, we will see if we can evaluate under terrestrial conditions. Of course, if you have the data, you can always do it as a summation of direct radiation from sunrise to sunset, and this is okay, minus omega s to plus omega s. But this difficulty is calculating 12 calculations or so, and then further you need the data. So, if I use it for the terrestrial conditions, I have to, I am designating it with R b bar T, which will depend upon the, of course, I b R b by sigma I b. These are either data values, or we will see what simplification can be made. So, this R b bar T is expressed in terms of the diffuse fraction just I is taken outside common. So, that I d by I is a known function. In fact, we have written it like this earlier when we were trying to prove that the extraterrestrial calculation is close to the terrestrial calculation if the daily clearness index is uniform throughout the day. So, this can be rewritten as in terms of clearness index and the extraterrestrial radiation. It is a similar steps that we had followed earlier so far. Now, what I can do is, though for the sake of our understanding, we first started with a summation of the hourly values. This can be rewritten as a continuous function, since we have the correlations of Colares, Pereira and Raoul and Liu and Jordan. So, integrate it. I is nothing but R t into H, and this I d is R d by R t into diffuse fraction d f times R b d omega by so where this d f is for simplicity h d by h. R d is I d by H d by I by H into H d by H. What I will be having is I is R t into H, I if it is taken out I d by I, that is what I will be having here. Okay. So, R d by R t into d f is nothing but I d by I. Okay. So, now this is a function, one you should have a little bold heart to look at this integration, and R t is a plus b cos omega times cos omega minus cos omega s sin omega s minus omega s cos omega s multiplied by pi by 24. I reduced one step, that gets cancelled with the denominator, and the other thing 1 minus I d by I, that is R d by R t is nothing but 1 upon a plus b cos omega. R d by R t is nothing but 1 plus a plus b cos omega, and you know that a and b are the two constants in the Colares-Pereira-Raoul's correlation for R t, which have been expressed in terms of omega s, multiplied by my R b, which is cosine theta upon cos theta z into d omega. So, the similar thing in the denominator, except this cos theta by cos theta z is not there. Now, this is all, one of the grad students was working on this some time back. The why pupil did not do, I do not know, it is a quite simple integration, except the success lies in the sin omega s minus omega s cos omega s should be can be written as cos phi cos delta cos omega minus cos omega s. Okay. That is this is cos theta z. Let us see. Okay. Just if you take out cos phi cos delta common, this is the term which gives you the fortuitous simplification, it gets cancelled with this cos omega minus cos omega s. So, now this starts shrinking, it becomes a smaller integral, a plus b cos omega into 1 minus d f by a plus b cos omega into cos theta d omega, and this cos theta z 1 by cos phi cos delta comes to the denominator, but cos omega minus cos omega s is cancelled with this. Then you have got further simplification, if you multiply a plus b cos omega minus d f times cos theta d omega upon cos phi cos delta times cos omega s. Now, if you express, so in a neat form, this goes on to the CET symbol by mind you, as far as we are concerned, this integration is concerned, a is a constant, b is a constant and df is a constant. Of course, cos omega s is a constant. So, we have written this again the same thing. Now, the highest order complexity is only cos squared omega. Integration will be b into this b cos omega will be giving me cos squared omega. To make you feel comfortable, cos squared omega has a simple integral is omega plus sin omega cos omega. The other thing somewhat less complicated is sin omega cos omega d omega, which is half of sin 2 omega d omega is minus 1/4 of cosine 2 omega. If you want to note down, I will write down cos squared that d omega is missing there. And you can have quite a good exhaustive tables on the web, even Wikipedia. So, you can see other functions also. So, I have struggled and numerator is expressed as I 1, that is integral 1, I 1 is the numerator and I 2 the denominator. So, they are both in terms of omega s s and omega s r. You can check the signs. I tried because I was doing this bit of algebra directly on the screen and I did not have the benefit of a old document in Word to directly take it. So, this was done. That A star which is a simplification is nothing but A minus d f. This acts like a single number. Now, when the surface receives sunshine at 2 time intervals, that is a so called double sunshine, it is straightforward to write the integrals I 1 and I 2 as is been done in expressing R b bar under extraterrestrial conditions. I mean, I did not want to write another 1 yard long relation for double sunshine periods. So, this gives a difference of about good 10 to 15% compared to the extraterrestrial calculations, particularly when gamma is not equal to 0, significant differences exist. Also, a fortunate rather redeeming feature is R b bar t, which we have analytically evaluated, is always almost closer to R B bar data. So, you take a location of Kharagpur, Calcutta, whatever, and use the data hour by hour, sum up I B R B upon I B, then calculate R B bar T with this formula, that will be closer to the data value compared to R B bar, which we have earlier calculated under extraterrestrial conditions. So, in other words, the Colares Pereira Raubal and Lewin Jordan, though they are analytical representations, capture the somewhat the realistic daily variation, and the success is not so much because of the distribution, but it contains the term df, diffuse fraction. Somehow we could bring in that any amount of radiation is not the same. What is the diffuse fraction? Consequently, it will be affecting your tilt factor, how much is the direct radiation received by the surface. So, this is because if you look at it a plus b cos omega into some term and that cos omega minus cos omega s, they are almost I 0 by h 0 with a modification by a plus b cos omega, which is also a geometric factor, nothing to do with the distribution of the data. Now, however, this d f that comes into the picture will attenuate or enhance R B bar evaluated under terrestrial conditions compared to the extraterrestrial value. Now, somebody can be a little greedy. Can we estimate for the year? In other words, we can always estimate given the data and given a computer and make 365 into 12 or even technically 24 hours calculations or 365 daily calculations or at least 12 monthly calculations. So, my R B bar y for the year should be H B bar j R B bar j by H B bar j. This is j is equal to 1 to 12 for the 12 months. Okay. Just like we have extended I B R B by I B for R B bar and H B R B by H B for R B bar month. So, for the year I am satisfied with the monthly average values, or one can construct in terms of the right up to hourly value. Now, can we be encouraged? We used delta is equal to delta m for the month. For the year, if I try to do that, a simple minded delta y will be 0, because it changes from minus 23 to plus 23. I take the average and I will get a 0, seems to be simple. And in other words, I am given, let us say, H b bar y or H y bar, from which I may be able to calculate diffuse radiation and then the direct radiation. So, this means I am trying to do this. As if it is a single day, I will calculate R b bar with delta equal to 0. Now, one will readily see the fallacy in this. What do you expect the, suppose a simple south facing surface, right, and some beta 40 degrees. latitude 40 degrees, or you can have anything, does not matter. I do not want to go to 66 beyond or less than 23, but any mid range latitude and the corresponding slope. Can you expect the number of sunshine hours will be more than 12 into 365 or less than 12 into 365 for the tilted surface? So, let us say n s year greater than 365 into 12 or less than 365 into 12 for the surface. Just a guesswork or trigonometry. We can readily say should be less than 365 into 12. I will give you additional piece of information just through mathematics. Anywhere on earth, average number of hours of sunshine during a year is 12, whether you go to North Pole or the equator. At the equator it is 12 all the days, and at the North Pole it is 24 hours into 6 months plus 0 into 24 0 into 6 months. So, the average is again 12 hours. Given this fact and comparing with the tilted surface, my NS is 12 or less for delta less than or equal to 0. That means, if I am having a negative declination, my physical sunrise and sunset hour angles are 12 or less than 12, and I restrict it to depending upon the value of phi minus beta to whatever is the value that you obtain by calculation. It is not more than the NS, whereas NS is less than twice omega s by 15 for delta greater than 0, because we restrict it according to the tan phi minus beta tan delta. So, my average will turn out to be less than 12, since the benefit of having a higher number of sunshine hours during delta greater than 0 is not allowed for the tilted surface. So, if I take delta equal to 0, my average sunshine hours, total number of sunshine hours will be 12 into 365, because every day we will be having 12 hours, and we put delta equal to 0, it becomes independent of phi, independent of phi minus beta. Consequently, I am very likely to get a incompatible value, if not a wrong value. Then the suggestion